All right, so my name is Jeff Yemin, and I'm an engineering manager at Tengen. And let me tell you a little bit about Tengen if you don't know anything about it. But first, what I'm going to talk about today is, as I said, just a little bit about Tengen, a brief intro to MongoDB, what it is, why it was built, what it's good for, a bit of talk about real-world applications, and particularly in terms of my own experience using MongoDB as a customer of Tengen before I joined the company, and finally a little bit about the community behind MongoDB and how you can be involved in the community. I'll make sure I leave time for questions at the end, but you can also jump in.
I just want to suggest something. I think it would help if you turn off these lights that are.
Yeah, just do that.
You have it back there?
Better?
Now I can't see any of y'all. Okay, so Tengen is there's a bit of confusion sometimes like what Tengen is, but because we mostly talk about MongoDB, but Tengen is the corporate entity behind MongoDB. We supply development. We do most of the main development of MongoDB. In addition, have support and services, including consulting, training, mostly production commercial support 24/7. We're growing really fast, like we have about 125 people now. When I joined in December, it was like, I don't know, 90, and a year ago it was like 15. I don't know, it's been very fast. The main office is in New York, where our CTO and CEO are. We also have a large office in Palo Alto, because a lot of our big customers are out there, and mostly some support and sales offices in London and Dublin, and that will be growing around the world. Funding is $31 million, and our investors are Sequoia, Flybridge, and Union Square. So, how many people here have actually used MongoDB? Right, so a lot of people. So I'm going to give an introduction to MongoDB, so please ask questions. Some of this might be a little low level for people who have used MongoDB, but bear with me. What's that? Oh, sorry, I thought you had a question. So what is MongoDB? It's a scalable, high-performance database. It's an open source database, so what that means is that anyone can use MongoDB who wants to use it, free of charge, and we only charge for commercial support. It has an AGPL license, which means that for the server, which means that anything you do, you have to contribute back. We also supply drivers for all the major languages, well, major and minor languages. I think we have drivers for about 13 languages now. But pretty much any language you might think of, we have a driver for. So what we call our database is a document-oriented database. I'll talk a little bit about what that is in a minute. But just briefly about the NoSQL space. This is a meeting about NoSQL in general. Like, my opinion about it is it's very difficult to describe what NoSQL is because it's really defined in terms of what it negates. Everyone knows what SQL is, but there's a great diversity of NoSQL databases, and they have, in some ways, the differences are bigger than the commonalities. So Mongo is a document-oriented database, which means we store, for us, means we're storing JSON documents, which I'll go into a little bit more later. But we're particularly focused on scalability. So the MongoDB came into being through the experience of our CTO, Elliot, and our CEO, Dwight, who had between them 25 years of experience building high-performance, highly scalable applications on top of mostly relational databases. Everything from DoubleClick, which Dwight was one of the founders of, to ShopWiki, where Elliot was a founder. And it was born out of their experiences trying to build databases both scaled for reads and for writes beyond what MySQL or Berkeley could do without a lot of customization. So they started this company originally actually to do a full web stack from like web server on down to the database. And there's actually a lot of code Elliot showed me a couple months ago. I'm reams and reams of Java code for a web server and all this stuff, but that they ended up throwing away and focusing entirely on the database because the feeling was that was the interesting problem. That and I think we see this even as more now even than 3 years ago, that there's just so much in the web space on the front end side that it's just such a busy space and really they felt the least of the harder and interesting, more difficult to solve problems were in the database space. So the focus is really building a high performance and scalable database, but also a database that's really powerful. So I'm going to talk about that in a bit, but just to talk about a few other parts of the database. So what we mean by scalable is that we can scale to multiple servers. If your data volumes get too big for a single server, what we call it auto sharding. So we'll have some slide for that a little bit later. We also do fast in-place updates. So it's like with a relational database, if you have an existing document, we have a lot of operators to change just the smallest piece of that document that you need to change for your application. We want to make sure that the database was a general purpose database. So the query support, it was always very important to have rich query support. So we have a very rich ad hoc query support for Mongo. But to support that for high performance, we also have full indexing support. So you can add secondary indices to make your queries really fast. And we also have support for MapReduce, but I'm not going to have time to get into that. So just in terms of how we see the database landscape, and I think every database vendor is going to see it through their own lens, so take it for what it's worth. But where we see it is that there's, on one axis we have scalability and performance, and on the other axis we have the depth of functionality, the feature set of the database. And there's a lot of really high performance stuff on this side where the key value stores where the depth of functionality is fairly small, like you can look up by key and you can store an opaque value. And on the other side, we have relational databases, which are really high on the functionality, but have more trouble scaling. What we're trying to do with Mongo is push Mongo out as far to the upper right quadrant as we can. So we want to have a database that has really rich functionality, but at the same time scales with your data and performs really well. Okay. So what is a document anyway? So a document is JSON. So I think everyone here probably knows what JSON is. So one of the kind of key aspects of it for our purposes are the nested structures of JSON. So it's not just single scalar values, that you can have arrays and you can have total nested subdocuments. So when you look at when you compare Mongo to a relational database, typically to do anything useful in a relational database, you need to modify multiple tables in a single transaction. So if you take a case like a purchase order and line items, you're going to have two tables joined together through a foreign key. But with Mongo, you can structure your documents so that you can put as much information that's suitable into a single document. So I can create a document that has purchase order and line items all as subdocuments. In this case, I'm talking about something else, but the same idea that I can have text of a blog or something with comments embedded in. Okay, so on top of that, we can do atomic updates. So there's a whole set of operators that are all prefixed with $, that you can use to do any sort of updates that you can imagine to a single document. So simple things are set and unset, but then there's also specialized operators to increment counters, to push and pull values from arrays and from so an example here is if I want to push a comment in this document, I can create a comment, and I can just say push this comment onto the list of comments. So if you go back to the previous document, that will push that to the end of this list of comments. So the reason why this is important is because MongoDB doesn't have transactions, so you can't, the unit of atomicity in MongoDB is a single document. So so you have to think about your your application a little bit differently, because if you need to have multiple documents updated, either both updated or not, you really can't do that. So you have to think about your application in terms of the structure of the application such that you put the information that needs to be together in a single document. Now there are ways around this, like you can do multi-document, you can do safe updates across multiple documents and without transactional semantics. There are ways to do it, but it's not as straightforward as you would with a relational database that has transactional support. In terms of querying, so again, I said we feel it's very important to have really rich query functionality in Mongo. We want it we've all seen you're sitting even just for ad hoc queries for quick reports or whatever. The ability to go into a shell or a GUI and just do any sort of query you want on a data set is really important. So, so we support that. And just like a relational database, you don't need to do anything special to do a query. Like you can create a collection with any documents you want, and you can start doing any query you want to do on that document set. You can do. So, example of that is if I want to query for documents where manja is on the list of tags, I can do that very easily. And so here we have a list of tags, so we'll find any document where manja is one of the members of that list. Additionally, I can query into subdocuments, so I can query where the author of a comment is Fred. So we can look here, we have comments about author is Fred. You can do that just as easily as you can query top-level documents. And there's also some support for aggregation, like count and group, although a lot of aggregation you have to do either with MapReduce or the aggregation framework that will be coming in 2.2. There's a rich set of operators, from all the conditional operators you might expect, and there's also even support for regex. You can run any regex search on a string. Interestingly about regex, by default regex can't use indices, but if you're doing a regex where you're anchoring it to the beginning of the string, you can use an index for that because it's a prefix query. So as I said, queries can be done without any indices, but obviously for speed, if you have any sort of collection of any realistic size, you're going to want to add indices, so you can add in any sort of index you want to your collections. You can index nested structures, you can index arrays, you can index scalar values, and you can do compound indices as well. Okay. So in terms of high availability and scaling, so there's basically we have two different mechanisms for those features of the database, I guess you could say. So for high availability, we have replica sets, and what a replica set is basically it's like if you've used master slave in MySQL, it's similar, except that with Mongo replica sets, there's automatic failover. So an example of that is you start with a primary and two secondaries. All the writes go to the primary because Mongo is a consistent database, so it's a single master database. So if you've used Couchadol, it's multi-master, but Mongo is always single master. And then there's an uplog in the primary that the secondaries are tailing asynchronously and replicating into the secondary. So you can only read from secondaries, you can't write to them, but by default you can't even read from secondaries. You're always doing reads from the primary unless you specifically say that you don't want to. The reason is because once you get into reading from secondaries, you encounter something called eventual consistency, which basically means that the secondaries are not always going to be in sync and up to date with the master. There's going to be some lag, and the lag can vary based on the load of the servers. So you can actually get into some difficult situations in your application if you're reading from slaves, where you write something to the primary and then you read from a slave expecting to see the write that you just did, and you don't actually see it. And a lot of we see people using slave OK reads where they run into this problem where they haven't tested this case in their application, and everything works fine in dev, but then when they get to production, they're using slave OK reads for scaling, and their application breaks down in certain circumstances when their replication lag gets too high. So you have to be careful. That's why we have the default as always reading from the primary, and the secondaries are used for disaster recovery and failover. Yes, in the back.
So, what would be a case for a benefit from reading from the secondary or just?
It's primarily for read scaling.
Okay.
So, if you can have as many as 11 secondaries, so you can take read load off the primary by reading from the secondaries. The other thing is geographic distribution. So if you have applications, some read-only applications, for example, that are in different data centers, you can arrange to read from secondaries that are in your data center. So secondaries can span data centers. We see people doing that all the time. Like you have different availability zones or regions, and putting one or more secondaries in each of those. Yeah.
I guess you do not offer a synchronous replication option at all, right?
Synchronous replication?
Right.
Well, we offer something called, so there's something called write concern, so by default, much to our chagrin, as I've said a bunch of times in the past few days, when MongoDB was first created, there was, the initial use cases were very much about analytics, so we made the default write concern basically what we call fire and forget, which means that if you start a driver, like you use any driver and you start writing to the database, the driver doesn't even wait for a response from the server before it returns control to your application. So that's what we call fire and forget. So obviously there's problems with that, because if you really need if you need that write to actually happen, you don't get notified that it doesn't. But there's different levels of write concern. So you can set a write concern of replica safe, which means that the write won't be acknowledged by the driver until it's replicated to any number of secondaries that you specify. So I think I always get it off by one error here, but if W is 1, then it means make sure it's replicated to at least one secondary. If it's 2, it replicates to 2 secondaries. And in the next release of the drivers, we're going to be adding tagged read. Actually, this is actually already there. We have the support for doing tagged writes, so you can tag different servers in different data centers. You can do things like make sure that this write was replicated to at least 2 data centers before the write is acknowledged. So it's synchronous from the perspective of the client doing the write from the driver, but the actual mechanism of replication between the server to the asynchronous. So quickly, what happens if, say your primary goes down, or there's a network split, and the other secondaries can't see the primary? There's heartbeat notifications being sent back and forth between all the members of the set. Eventually, these 2 secondaries will notice that they can't talk to the primary. They'll say, "Oh, but we still have a majority of members in the replica set, so we're going to elect a new primary." So one of the secondaries will be elected primary. The drivers will detect this and start writing to the primary and reading from the primary by default. And then when that node comes online, or you fix your firewall configuration, the former primary will come back and join the replica set as a secondary. Yeah?
How seamless is this promotion of a secondary to primary? Does anybody else need to realize? I mean, does Mongo?
Yeah, so the problem, what you have to, it's not entirely seamless because the election process can take a little while, so there can be several seconds where there's no primary at all while the election is happening. And during that time, your application won't be able to write. So you do have to handle that situation. It's no different from any other database that you might lose connectivity to from your application. You have to handle that situation. We can't really do anything like that smart, because the problem is that when in just kind of distributed computing 101, we don't know whether the write happened or not in some cases. So we can't just retry the write because the write might have already happened, and we don't know if the write is idempotent. Like if you're doing an increment and we do it twice and both of them actually succeeded, you could get a double increment. So we have to leave it up to the application to determine what to do when you can't reach a primary.
And is there any manual step involved for the clients to realize that there is a new primary?
You'll get an exception. So yeah, there is that's the manual step. You have to catch an exception and then handle that situation in your application.
So since the writes are asynchronous, does it mean that it's possible to lose data when the primary goes down and it's not didn't get replicated to secondaries yet?
So there's a bunch of different write concerns that you can use depending on how safe you want the write to be.
By default,
By default, there's no safety at all. You can definitely lose your writes. So you have to be aware in the drivers to set the write concern to what you want it to be, because the default might not be what you want. Frankly, it's something that we regret. It's caused us a lot of pain, kind of just in the blogosphere, but more to the point, like we're more concerned with actual customers or people using Mongo losing data that they didn't expect, because with the database you expect your writes people generally expect their writes to succeed by default, and it makes more sense looking back on it to make that the default. But it's not, so you have to set the write concern appropriately. So you can do what's called like a journal safe write, for example, where it makes sure that it's written to the journal before it's acknowledged. Okay, so that's the HA story. Scalability is auto sharding. So I don't have a lot of time, so I'm going to blast through this really quickly. With auto sharding, each shard is a replica set, so that each shard is highly available. But then each shard handles, sorry, back a sec. A collection, you shard on the level of an individual collection. So you tell Mongo that you want to shard a particular collection, and it starts distributing the collection across all the shards that you've set up in advance. We organize shards by key range. So Mongo will take charge of dividing up your collection into chunks according to the key range. The way you specify a key range is something called a shard key. So the one thing you do have to do with sharding that's a little different is you have to pick your shard key in advance. So a shard key, I'd say, yeah, the shard key can be anything you want, but you have to make sure it distributes your writes and reads as necessary. And to abstract this from the application, there's router. There's these router components called Mongo S's, which abstract the shards from your application. So the driver talks to the Mongo S's, and the Mongo S's are responsible for talking to the shards. The shards will take care of distributing the writes to the appropriate shard according to the shard key. You can figure out which shard any update can go to. And same with queries. Like you can do queries that only go to a single shard, or the Mongo S can do like a scatter gather on the queries. All right. So use cases. We have a lot of customers using Mongo for a lot of different things, which I think proves out our hypothesis that Mongo can be a general purpose database. So everything from analytics to content management to e-commerce even, though that might be surprising to some. Advertising, gaming, social networking. And briefly, I actually came over to Tengen from Viacom, from MTV Networks. If anyone came to MongoDB Boston last year, I spoke on the subject, but briefly we built a CMS in MongoDB because we had this problem. We had a huge amount of content types, and to try to model all those content types in a relational database, we had been down that road and really failed. And when it came time to try to pick a new database that handled the generic CMS that we were trying to build, Mongo was a really good fit for it. So I was a customer of Tengen for a while, and as a customer, I was very impressed with the commercial support that we got and the general level of responsiveness of engineers and everyone in Tengen. So that's why I decided to join myself. Last thing is community. We have MongoDB days all around the country and the world. There's Mongo Boston was last October, I think, and there'll be another one this October. There's Mongo NYC is in May if anyone wants to come sooner than that. We have a users group in Boston, the Boston Mug. There's a URL for it there, but if you just search for a users group, Mongo Boston, you'll find it. And finally, user forum for free support. We do a lot of free support, even if you're not a customer. We answer I think we have 15,000 free support tickets that we've closed since we started, so we invest a lot of time and effort in that. And finally, we're thinking about starting office hours because I live in Wayland actually, and so I'm trying to think about where to do office hours. So if anyone has any suggestions about where we should do it, what's up? Well, yeah, I can do it in Wayland. That'd be great for me. But if anyone has suggestions on where we could do it, that would be good to know. All right, thank you very much, and I'll be here after if you want to talk further.